In my prior video, I discussed gas-gas reactions in combustion chemistry. In this video, I switch my focus to wet chemistry and reactions that occur in solution. I will start by talking about solvents. Combustion chemistry is mostly gases reacting with other gases. Another, possibly more important type of chemical reaction occurs in dissolved solutions. Solvent means to solve or untie, as in untie or solve a knot. In the case of chemical solvents, it is molecular bonds that are untied. A solvent may be a gas, liquid, or solid, but for most of chemistry, we are talking about liquid solvents. A solvent is any substance that will cause another substance to dissolve within it. The dissolved substance is the solute, and the mixture of solute and solvent is called a solution. It is common to indicate a substance X is dissolved in water with the subscript AQ. The AQ means aqueous, as in X parentheses AQ, to indicate the substance X is dissolved in an aqueous solution or water solution. Solvents can be nonpolar, aprotic polar, or protic polar. A common rule is like dissolves like, so nonpolar solvents dissolve nonpolar substances, and polar solvents dissolve polar substances. Protic solvents dissolve by hydrogen bonding, and aprotic solvents do not use hydrogen bonding. Nonpolar solvents include pentane, hexane, benzene, and toluene. These nonpolar solvents dissolve nonpolar substances that include grease, oil, and oil-based paints. Ether and chloroform are also nonpolar solvents. Ether can be used as an engine starting fluid or to anesthetize the patient before surgery. As a solvent, ether is used in the plastics industry. Chloroform is another nonpolar solvent that can be used as an anesthetic or can be used as a gasoline additive. As a solvent, chloroform is used in plastic production and to dissolve fats, oils, and waxes. Polar aprotic solvents include acetone, DMSO, and nitromethane. Acetone is used to dissolve or remove nail polish or to thin oil-based paint. Dimethyl sulfoxide, DMSO, is commonly used to dissolve drug compounds. Nitromethane is used as a solvent to manufacture pesticides, explosives, and synthetic fibers. Nitromethane is used to dissolve acrylate monomers such as cyanoacrylates, also known as superglues. Nitromethane is also used as a fuel for model airplanes and top fuel drag racing. Polar protic solvents include the alcohols ethanol C2H6O, methanol CH4O, and isopropyl alcohol C3H8O. Water H2O is also a polar protic solvent. Alcohols defy the like dissolves like rule. Despite being polar protic solvents, alcohols are near universal solvents for both polar and nonpolar substances. Alcohols can straddle the polar-nonpolar fence because although alcohols are polar, they are not as polar as water. Highly polar substances like salt dissolve in alcohol, just not with the same solubility as in water. For example, at 25 degrees Celsius, up to 360 grams per liter of sodium chloride NaCl will dissolve in water. At 25 degrees Celsius, only 14.9 grams per liter of sodium chloride will dissolve in methanol. So, as a solvent for sodium chloride, water is almost 25 times better than methanol. On the other hand, petroleum-based nonpolar oil and grease will dissolve in alcohol but not in water. Alcohol dissolves or otherwise harms the three most important components of life: lipids, proteins, and nucleic acids. Cell membranes are composed of lipids and fatty acids. Alcohol's ability to dissolve lipids and fatty acids tears cell membranes apart, killing the cells. Alcohol's ability to dissolve lipids in cell membranes make it a great sterilizing agent and antiseptic. Ethyl alcohol and isopropyl alcohol denature proteins or break the hydrogen bonds that help the protein maintain the shape crucial to their function. DNA molecules will remain suspended in water unharmed. When ethyl alcohol or isopropyl alcohol are added to water, the polar properties of the alcohol cause the DNA to concentrate or separate out of the suspension. Geneticists use alcohol to extract DNA, but such extraction methods kill any life dependent on the DNA. By far, the most common polar protic solvent in chemistry is water, H2O. Water is an excellent solvent of polar substances like sugars, salts, and ionically bonded compounds, both organic and inorganic. The fact that water is both abundant and a very good solvent is crucial to the biology of life on Earth. Water as a solvent allows sugars and ions to remain in solution and be transported about the body or within living cells for use as nutrients or in life functions. Lipids and fatty acids are immiscible and hydrophobic and so do not dissolve in water. The hydrophobic nature of lipids cause them to naturally form spherical vessels or cell membranes when lipids are placed in water. Water's polar properties promote the function of lipid cell membranes, the proper folding of proteins, and the suspension of nucleic acids, including DNA, all make life possible. By making life possible, water is the most important solvent in the universe. Before we get into biochemistry, we will learn about acids and bases and battery reactions. Sugar and salts readily dissolve in water. Common table salt, or sodium chloride, NaCl, is ionically bonded, and when poured into water, dissolves into sodium ions, Na+, and chlorine ions, Cl-. In the equation, the S indicates a solid, and the AQ indicates an aqueous or water solution. The highly polar water molecules act to pull the sodium and chlorine ions apart through hydrogen bonding. At room temperature, 25 degrees Celsius or 77 degrees Fahrenheit, almost 360 grams of NaCl can dissolve in a liter of water, 1,000 grams of H2O. The salinity of the ocean is on average 35 grams per kilogram of water, although the salinity of the Arctic Ocean is less than 30 grams per kilogram of water, and the salinity of the Mediterranean Sea is as high as 38 grams per kilogram of water. The dissolved salt is an electrolyte and increases the water's electrical conductivity. Distilled water has an electrical conductivity of nearly 5 times 10 to the negative 7th per ohm centimeter. Seawater can have an electrical conductivity of nearly 5 times 10 to the negative 2 per ohm centimeter. So salt water or seawater conducts electricity nearly 100,000 times better than distilled water. When electrodes, a cathode and an anode, are placed in a tank of salt water, the electrons don't actually pass through the solution. The cathode provides electrons to the water, H2O, liberating hydrogen gas bubbles, H2, and negatively charged hydroxide ions, OH negative, in the cathode reaction shown. At the anode, the NaCl is dissociated, liberating positively charged sodium ions, Na+, chlorine gas, Cl2, and electrons which enter the anode and complete the circuit. So the anode reaction is shown. The sodium ions, Na+, bond with the hydroxide ions, OH negative, result in the formation of sodium hydroxide. An electrolytic cell to produce chlorine gas, hydrogen gas, and sodium hydroxide is shown in the figure. Another crystalline solid that readily dissolves in water is common sugar or sucrose. Sucrose has the chemical formula C12H22O11. A sugar crystal is made up of millions of sugar molecules. Sugar is a polar molecule like salt. The polarized water molecules act on the OH branches of the sugar molecules to pull the sugar crystal apart by hydrogen bonding. And though the sugar crystal is pulled apart, the sugar molecules themselves are not pulled apart. Sugar molecules do not break apart into ions the way sodium chloride salt does. So sugar water is no more electrically conductive than fresh water. There are no ions present to transfer the electric current from cathode to anode as there is in salt water. And that concludes my discussion of solvents and solutions. For my next topic, I will discuss acids and bases. Thank you for watching.